Don't worry about it. It's okay. Okay. I'm just going to keep going.
Yeah, go for it.
Hey, everybody. Hi. Thanks for having us to BSides Cleveland. Much appreciated. This is Pentesting Layers 2 and 3. My name is Kevin. This is Eric. And we're here to talk about security issues with Layer 2 and Layer 3 networking protocols. So we'll just do a quick overview. We'll talk about the background of this, the threat surface, the targets and attacks, and the defenses, some of the tools that you can use for this stuff, the platforms that the attacks can be launched from. We'll do a couple demonstrations and then do a little Q&A. But just a quick question. Who here in the room has dealt with configuring a router or a switch as a part of their job? Awesome. That's great. So this is targeted right to you guys. This is good stuff. So my name is Kevin Gennuso. I'm a security testing manager. I lead a team of pen testers, and we do all kinds of fun stuff in that. I've been doing InfoSec for a while and networking for even longer than that. I got a bunch of alphabet soup, but this isn't LinkedIn, so we're not going to talk about that. My first network gear is a Hayes Smart Modem 9600. Oh, look at that little buddy, you know? And this is Eric.
Hi, I'm Eric. I'm also microphonically challenged, so I'll probably pull this away from me more times than I'll care to admit. I am a recovering software developer where I no longer do that anymore, and I'm quite happy about that, thank you. So I've got a background in managing both software and networking hardware for PCI, HIPAA, and all the fun stuff. I am an application security hardener, and my job now is to yell at developers to try to teach them to, stop being stupid, basically.
Hello. I should have warned you. I was trying to resync another microphone. Is this working? Test, test, test. Okay, we'll keep doing it.
Hello, hello. Hey, check, check. Check, check. We'll keep going. So, anyway, it's very well known, and you feel a little dirty anytime you do ARP attacks because it's a little unfair. You know, what are you going to do? So, some ARP defenses. There's port security and 802.1x. This is really good stuff. This is making sure that anybody jacking into your network provides credentials. Unfortunately, it's been defeated, but it's a very good thing to try to get implemented in your network, especially for this and especially for all of this type of stuff. Another prevention is Cisco has this in their networks. Thank you. It's dynamic ARP inspection, which is actually verifying the MAC to IP mappings. It also allows you to rate limit ARP packets. So if somebody's going to come to you and try to flood your CAM table, it's not going to work. You're going to limit the number of ARPs that are allowed to come from a particular IP. You can also do something old school, which is static ARP entries. If you got a super sensitive system, then why not statically set those MAC addresses in the ARP cache for sensitive hosts? That prevents all these other attacks from happening because this guy's never going to even use ARP. He's going to look up in his local cache and say, oh, that's the MAC address, that's the IP address. And then there's ARP Watch or IDS. It'll pick up, you know, ARP noise and ARP attacks, but that's assuming you have IDS deployed to places where ARP attacks can happen, like at the desktop. So, not the easiest thing in the world. The next one we'll talk about is Cisco Discovery Protocol. This is a really interesting one. It's a multicast protocol, so it gets blasted out to the entire subnet. It advertises the device's capabilities. So I'm a router, I'm a switch, I'm a phone, right? And it's really used for voice VLAN determination. So if something on a Cisco network in particular says, hey, I'm going to advertise my CDP and say I'm a phone, well, the Cisco switch is just going to say, okay, let me put you on the voice VLAN. No big deal. And like any layer 2 or layer 3 protocol, it obeys the rule of no authentication. There's a theme building here. Some CDP attacks. Well, you could be a jerk and flood the CDP table. It's actually a very effective denial of service attack. You could also troll your network admins and just start adding random devices, which I don't know what that achieves except for being a jerk, but you know. The interesting one is to actually be able to jump onto other VLANs. Again, if you can say, hey, guess what, Cisco switch, I'm a phone. Well, now you're on the voice VLAN. Well, isn't that a nice place to be? Because now you can listen to phone calls. Unless you have encryption turned on, which I'm sure everyone does. Some CDP defense, turn it off. No CDP run is the command to do that. I wish they had a never CDP run, a never ever CDP run. That's what they should have. Just give your phones their own ports and don't let that determination happen. Now that's expensive because now you're burning a port on a phone and burning a port on a PC. But do you want to be secure or not, right? It's the old convenience versus security argument. And again, port security and 802.1x, sound familiar? That'll help you here. Next, we'll talk about DHCP. You know all about it. Everybody uses it. It's about IP address leasing, gives you your default gateway, your DNS. But something that you might not think about is TFTP. So if you got something that boots via PXE, a Pixie boot device, or a voice device, or a thin client that gets information from DHCP and says, okay, download your firmware from here, that can come from DHCP as well. So as an attacker, it's kind of interesting to own that. And wireless controllers as well behave in that same manner, where they boot up, look for some DHCP options, and pull down their firmware based on what DHCP says they should do. It's broadcast across an entire subnet, and like any good layer 2, layer 3 protocol, there is no authentication associated with DHCP. So some attacks: be a jerk, exhaust the DHCP pool, send the clients bad addresses, then they're going nowhere. You can do a lot better things by just supplying rogue default gateway, DNS, TFTP information, because now you can send people to you. You can become the man in the middle for the gateway. You can supply bad DNS information. You can boot from my firmware that I own, because now I'm sending your phones or your wireless controllers my firmware, or pretend to be the Wi-Fi controller, which could essentially allow you to own the entire Wi-Fi network, however many access points they have out there. So what do? Oh my goodness. Oh yeah, port security, 802.1x. Very, very good way to defeat this attack. DHCP snooping is also a good idea, where you set trusted DHCP servers, and if you see DHCP servers pop up that aren't allowed to be talking DHCP, you just shut those ports down. And there's a number of switches that have this feature out there. It's actually required for Cisco's dynamic ARP inspection. You could also use DHCP find or IDS, something that's looking for these rogue DHCP servers. We'll go on to dynamic trunking protocol, another Cisco protocol. It's a proprietary thing. It's used for trunking VLANs between switches, and it's set to auto-negotiate on all ports out of the box. So all you have to do is come to the switch and say, hey, I want to trunk with you. Give me all your VLANs. If you're saying that to the switch is set to auto-negotiate, it's like, great, here you go, man, let's do it. Here's all my VLANs. And like any layer 2, layer 3 protocol, there's no authentication whatsoever. So what can you do with it? Well, you can trunk all VLANs out too far. Extend your VLANs out hundreds and hundreds of hops away. That'll just take the VLAN down. But to really do bad things, you can trunk VLANs to the attacker box. And depending on what's available on the switch, maybe a lazy network admin might have all VLANs on all switches, including the internal network, the DMZ, the dirty outside. Depends on how things are set up. It could be a really juicy list. You could have full access to every VLAN on the network. So if that's the case, you better be sure that you're beefy with the router that you're trying to do this with. Oh my goodness, what do? Well, it's really easy. Switch port no negotiate is the command to shut it down. Switch port never negotiate, never ever negotiate. That's what should really be there, right? But again, port security, 802.1x, don't allow rogue devices to attach to your network. Beating the horse. We're just beating it. Now, you gotta love HSSRP and VRRP. These are redundancy protocols that are meant to allow you to set up a primary and a secondary default gateway, layer 3 gateway. HSSRP is the Cisco proprietary, but VRRP is used by everybody else. It's about layer 3 redundancy. You have a shared MAC address and a shared IP address that are used by participants in this little cluster that you build. And it's using clear text authentication. It's a multicast protocol, so it gets blasted out to every node on the subnet. And when you have clear text authentication that's getting blasted out to every node on the network, it's as good as no authentication. You can sniff that stuff, no problem. So obeying the rules of layer 2 and layer 3 protocols, no authentication. So what can we do? Well, you can send clients to nowhere. That's not very useful. The more interesting thing to do is to become the primary router, because now everybody's coming to you and you don't have to do any of this ARP spoofing, cam table filling crap. It's easier than any other method, very elegant, and if you do it right, your clients won't even know it's happening. The people that you're grabbing won't even see it. And just to demonstrate what this attack looks like, we have our obligatory ski mask hacker, right? I know when I'm on a pen test, I got my ski mask on, my silver tie, right? You got to have it. So in the normal world, we have our flock, which we're trying to protect. The poor jerks are supposed to be going like that, right? Out the primary, no problem. But in the attack scenario, what happens is this guy says to the two routers, hey, I'm primary. And so the primary says, all right, I'll be secondary then. And the actual secondary says, sweet, I'm out. I'm not, you guys do whatever you want to do. It's cool. And so what ends up happening is the sheep actually first go to the attacker router, then the attacker routes them out the actual valid route and then sends them out to the world. So ultimate man-in-the-middle attack right here, right? What do? Well, we have the option for MD5 authentication, okay? It's not turned on by default. By default, the password is Cisco. It's clear text. It's just sitting out there. You know, and MD5 is broken. We know this, but it's better than nothing. It's better than clear text, you know, throwing the authentication out there. So there's that. The other thing is to log failovers and treat them as potential security events. Your network admins might see a failover and say, okay, good, the network survived. They might not realize that somebody just owned a network segment and is, you know, acting as man in the middle. So log those failovers and treat them as actual events. And then, dear Cisco and the VRRP devs, really? Like MD5, this is 2014, we're still using this, you know. So what you could do is get a better redundancy protocol. Unfortunately, it's a little tough. The only folks that have one are the OpenBSD people. They have something called CARP, and it uses SHA-1 for the authentication string. It also encapsulates the redundancy IP address inside of that SHA-1 packet, so none of it can be seen. Not the authentication string and not the failover address. Very good stuff. We'll move on to spanning tree protocol. You gotta love spanning tree or rapid spanning tree, which is the another version of it, another iteration. Cisco has their own proprietary, of course, PVST and PVST plus. It's about preventing network loops. That's what spanning tree protocol does, right? It's a great idea. You can't have loops in a network, otherwise the network dies. So spanning tree protocol looks for BPDUs, bridge protocol data units, and uses those to detect where a possible loop might be and blocks the ports where those loops are. So that prevents the loops from happening, but if one of those redundant links goes away, the path changes and now you have redundancy. It's great. We elect a root switch in that process. It's a little buggy, but you know that's how it goes. And I don't know if you can imagine this, but there's no authentication with this protocol. It obeys the rule of no authentication. So what can we do with it? Well, you can be a jerk. You could make some BDPUs and create loops instead of preventing them. That's a good time. That'll shut a network down real quick. If you want to distract someone, this is a really easy way to do it. A better way to do things is to become the root bridge. Tell all the switches in the network, hey, come to me first. I'm the guy at the center of the network. Please send all your traffic to me. And it's not your standard man in the middle. There's little to no impact to users if you do this attack. You have to do it right, though. There's about a 30-second failover before the network path changes. Very wide scope that you can have with this if you're in the right place in the network. So you've got to be beefy, serious hardware if you're going to do something like this. What do? Oh my goodness, it's terrible. Well, we could stop using it. There's an option. We've grown beyond spanning tree with technology. LACP, which is Link Aggregation Control Protocol, allows you to bind multiple links together. You combine that with some switch stacks that are virtualized, and you can make your network appear to be one single path and having no loops whatsoever, even though you do have redundant paths built in. So that's a very good way to prevent this attack. But since that costs big money, this is not cheap stuff, you could disable STP on non-trunk ports. Out of the box, it's enabled. Just disable them on ports that aren't trunking. You know, enable BPDU guard. You know, it's a feature that came out not very long ago, 2005. So turn it on. You have to turn it on for it to work. And enable root guard, again, so that I can't just become root. You designate your root. You can also hope for no more bugs. So just stay patched on your network gear. Everybody forgets to stay patched on the network gear. You got to stay patched on your network gear just like you stay patched on your Windows box. And that's layer 2. So we'll move on to layer 3. Does anybody have any questions? All right. We'll move on to layer 3. We'll talk routing protocols. OSPF, IGRP, EIGRP, RIP, which, ew, please don't use RIP anymore. It's a control, this is to control routing on the LAN. And so, just these are LAN routing protocols. BGP is a WAN routing protocol. You're talking global routing of internet traffic. And you can see OSPF and EIGRP in like local WANs, but you're not talking global internet type stuff, right? It's important stuff, right? This is control of your network traffic. So you probably want to worry about it. So what can you do with it? Sorry, no authentication here either. Out of the box. There's support for it, but out of the box, no authentication. So what can you do with it? Well, with OSPF and IGRP, EIGRP, RIP, you can send these packets to control, if a router cares about hearing these packets, it'll let you own the LAN or own the corporate WAN. With BGP, if you're able to send packets, BGP packets to a router that will listen to you, you can control the path that a company or a target's internet traffic takes. Very big deal. And this is happening right now in the world where certain organizations are being targeted, and then all of a sudden one day their internet traffic runs through Pakistan for a day or runs through Iceland for a couple hours, and who knows what happened during that time. This has been observed over and over again in the last couple years. So what do we do? When it comes to OSPF and IGRP and these types of protocols, listen only where you have to. That's the command to do it. That's not the command that's out of the box, but that's the command to do it. Everybody should be doing this. Require authentication. There is the ability to turn on an MD5 hash for all these protocols. Cisco goes the extra step of having control plane policing, which is pretty much an access list for what protocols the device will process. And so you can rate limit or just deny all traffic across the entire device. Don't even let it into the CPU of the device. When it comes to defending against BGP attacks, require authentication, very good idea, except that requires coordination with your ISP. Some ISPs will tell you, sorry, that's hard to do. We don't support that. And then you just escalate that to the right person in the organization, and then they'll turn it on for you. But they will push back at first. Same with the TTL security check. So the trick with that is you're actually checking to make sure how many hops away your peer is. And that's something that's supported across many different devices. ISPs should support it, but sometimes they push back as well. So it's something you have to work with them on. Make sure you get a decent ISP. Access control list is a great way. Only accept BGP from systems that you expect BGP to be sending to you. You can set max prefixes so that somebody can't just flood your BGP table with a bunch of invalid prefixes, saying that the internet is 5 times as big as it is. That's a great way to take your router down. You can also filter inbound prefixes or set the limit on how many hops away, the AS path length that you're actually taking. And control plane policing, I mentioned that before. Just kill it all. It's like a firewall for the CPU of the router. Okay, and then we'll move on to some of the tools to do this stuff. I'll give this to Eric.
All right, I like to say Kevin and I's working relationship is more like I'm the DJ and he's the rapper. So a while ago, Kevin came up with this great idea. He's like, hey, let's attack some network stuff. He's like, can you write that? I'm like, yeah, I can tear apart a protocol. And before any of us realized it, there was a lot of tools out there already for it. You know, if only I thought that there was an interconnected web of computers where I could look up information, I wouldn't have had to spend a lot of time on that. Who knew? So anyway, I started looking through the tools. I think we both discovered them about the same time. One of the first ones we moved over was Nemesis, which is a command line packet crafting and injection tool. It supports numerous protocols. You can do payload files from standard in. And the last update was 2002, but luckily, it's still valid today. It is, yes, the godfather of all packet creation tools. So EtherPuppet. EtherPuppet was wonderful. I actually did not have to do anything to bring it over to our platform. It replicates traffic from one network interface to a remote host, and it would be wonderful if you had a device that had multiple interfaces to it. So that's what we're using it for. So you can control it remotely. You can send traffic anywhere from the LAN to WAN, wherever you want. It supports SSH tunneling. If you had multiple interfaces where somebody could not look at how you're commanding it, it might be the perfect tool for that. And yes, it is available online, and you can just download it. Don't have to do anything with that. I should also state that a lot of this project was having to learn how to cross-compile for OpenWRT as well as the MIPS architecture that's in here. So that was actually the bulk of my time, was figuring out how the heck to do cross-compiling. And if anybody's thinking about it, I highly recommend just building from source and creating all the tools from that. And don't waste your time trying to find things that are already built, because it's not going to work. Another tool that we have is ScapeE. It is first released in 2005. I believe it is written in Python. I did not have to do anything for it because out of the box, the Pineapple supports Python. So I'm sure we all have run Python. It's right there. Semi-frequent updates, community support. What else do you want? One of the last tools I brought over was voidpopper. So with voidpopper, we are able to make this look like a phone and hop onto the VLAN. Multiple support, multiple vendor support, supports all the big names: Cisco, Alcatel, Avaya, Nortel. Lots of fun. It's regularly updated, which, I don't know, we're talking about old protocols here, so regularly is variable depending upon your thoughts. Another tool that we brought over was your Sheena for attacking layer 2. It's a toolkit, it's command line interface and NC nurses. If you're running it on, excuse me, Kali Linux, there is a user interface for it that's graphical. We had to strip that out. It does active sniffing. Some functionality is broken. At first, I thought it was me compiling things wrong, but no, it is actually broken in Kali as well. So luckily, I didn't break anything. It's always wonderful. It's great for low bandwidth ops, very infrequent updates. So yeah. So some of the other tools which I have tried to move over, but for various reasons have failed, and a lot of it's mostly just time, would be IRPass, released in 2001, supports many protocols, has one of my favorite binaries there, which is Autonomous System Scanner. Does HPing3 is another one. It's got similar functionality to Nessus and ScapeE.
Let's talk about AS for a second, okay? This tool in particular is really scary, because if you're going to attack EIGRP or one of the other layer 3 routing protocols, you need to figure out the autonomous system. And if you haven't sniffed it, you can just use this thing to scan for it. It'll scan across your network and respond positively whenever you've guessed the autonomous system number. It's like 2,000. Depending on the protocol, you go anywhere from 1 up to like 2,000, 3,000, and that's about the max. So you'll find it pretty quick, and nobody will ever detect you running that type of scan.
Again, I'm the DJ. He's the rapper. Some other tools, Loki, it would be a love to have this. It is mostly written in Python. There is some compiled aspects to it that does create the GUI interface to it. I'm in various stages of ripping that apart. It's pretty heavy, especially since I've never worked with that GUI on it. Not a lot of fun, kind of boring. Once it gets running, it'll be kind of cool. NPing, released in 2003 with Nmap, and it's a lot like HPing3. And of course, in order to do that, I had to build OpenWRT on my laptop and build it from source. It created the cross-compiler toolchain for me. And once I finally figured that out, we were good to go. However, it was not fun getting there.
Thank you, sir. So when we talk about the platform, there are many, many, many ways to do this. You can do it with a laptop or a Raspberry Pi run in Kali. You can do it with any of the Pony Express tools that are out there. They're very expensive, but man, are they slick. The Pwn phone, take a look at that thing. If you haven't seen it, it's pretty scary. Rooted Android device can do a lot of this stuff too. And so can PowerShell. PowerShell can write raw packets and Dave Kennedy was talking about a little bit in the keynote, it's typically allowed, it's whitelisted on all your systems. So you can just write raw packets out of PowerShell and do every one of these attacks, every single one. Or you can do it with a Wi-Fi router that can run OpenWRT. And since router's going to route, our flavor of choice was Pineapple. So in case you haven't heard about this little device, and I'm sure most of the folks in this room have, it's OpenWRT running on 400 megahertz MIPS system on a chip. It's a dual-core chip, 16 megs ROM, 64 megs DDR2 RAM, which equals powerful. This is a powerful little thing when you're going up against old, antiquated network gear. 4 potential network interfaces. 2 of them are wireless, 1 of them is wired, and then you can use the USB port to plug in a 3G or 4G modem and access it over the cellular network. So, yikes. And it has support for over 300 mobile broadband modems. We got a couple of them up here. There's a picture of it. Anybody wants to take a look, that's all it is. Runs off a battery if you want it to. It has support for big data. Micro SD card supports up to 32 gigs of storage, so that's fantastic. You get 2 gigs out of the box. The USB can also be mounted as disk, so whatever you need. Like I said, battery powered. It has dip switches on it that make it unbrickable. You can do as many bad things, as many stupid things to this thing as you want, trying to hack it to death. You flip a couple switches in the back, and it'll be back like it came right out of the box, and you can restore from there. So that's slick. And then you have all kinds of tools available that come pre-installed. We haven't even talked about the Wi-Fi aspect of this thing. That's what this thing is for. It's for attacking Wi-Fi. But we're talking about, let's go back to just straight up layer 2 and layer 3 networks. So there's all kinds of tools that are very helpful on there. It also has a serial port and an expansion bus and a very funny name. It's a good feature. So let's talk about exploit chaining a little bit with some of the things that you can do here. So if I take the HSSRP attack and I combine it with EtherPuppet, which allows me to basically have Wireshark, except sending everything Wireshark sees out to my receiving host on the internet. That means remote sniffing of an entire VLAN. That's what that is. If I do voidpopper and combine that with the HSSRP attack, well, that means I'm hearing phone calls across an entire VLAN remotely. Pretty good stuff, right? If I do the DTP attack plus the HSSRP attack, I can grab network traffic across many VLANs. And if I do a spanning tree attack, that could potentially lead to grabbing all traffic across all VLANs. So pretty wild stuff in such a small package. Now, if we think about a layer 2-3 attack, any of these that we've been discussing so far, plus DNS Spoof, which comes on this Pineapple, plus SSL strip, which strips, just like the name says, it strips SSL off of the connection and forces everybody over HTTP. Plus fake login pages, which can be hosted right on this device. You know, a gmail.com can be hosted right here, or at least something that looks like it. Plus on-device storage, plus remote connectivity over Wi-Fi or 3G, 4G. That means game over, okay? That means we just own the entire thing. Okay, so somehow we're 35 minutes in and we're already at the demo, which is much better in Pittsburgh. So we'll do a little bit of a demo here if everybody doesn't mind. So this is HERP and DERP. These are 2 routers that I have sitting in my basement. They are ancient. They're one is a 2621. The other one is a 3721, I believe. It's old stuff for sure. It might interest you to know that a recent study that was done against the aging of network gear out in the world, and 52% of network gear currently in use by Fortune 1000 companies is obsolete. That's not just old. It's not supported by the vendor anymore. You can't get patches for it anymore. It's ancient. You can't get support. If it dies, you better have one on the shelf because you're not going to get anybody to come out and replace it. So that's an interesting statistic, you know. So these are still in use all over the place, you know. And I had a couple of them. Would have loved to bring them here, but they would have probably drowned out the entire area down here. You wouldn't be able to hear me right now. One of them, the fan is just not, it doesn't sound good. So what we went with was GNS3, which some of you networking people might know what this is. This is an emulation utility. It's actually a hardware emulation suite that allows you to load in Cisco iOS images into it, and it will run that software as if it was the hardware that was sitting in my basement floor. So that's what we used, and that's what we're going to use here to do the demo. So if you wouldn't mind, sir. Get this fired up. Okay, so this is our network topology, okay? This is just a general network diagram of what we're going to demo right here. We have this Mac connected to a Pineapple right here. And then we're using Windows 7 VM because GNS3 works best on Windows, at least that's my experience. And we're emulating a switch that's a dummy switch. GNS3 cannot do Cisco switches. So unfortunately, we can't look at that, but we can look at HERP and DERP that are connected to a layer 2 switch. So let's start up the nodes. Okay, and this is green now. So we should just be able to console right in. See, look familiar? This is a ye olde Cisco box. Would you mind? Thanks. Okay, and so this right here, the speak and standby, these are HSRP messages that are coming across. So HERP. HERP is currently acting as the active router. If you look right here, oops, active router is local, okay? And this guy's standby. So very straightforward. So what we're going to do is we're going to fire up Yersinia and just take a look at some of these packets. So this is our Pineapple. Launch this in interactive mode. Okay, and as you can see, I don't know if you see the packet counts going up over here. See, we see some packet counts going up. So the way Yersinia works is it has this really slick kind of interface that works really well over like low bandwidth connections and that kind of stuff, over like cellular network, whatever. And it lets you choose, let's take a look at HSRP packets. So it's kind of like an easier to use sniffer because it's telling you straight up, it's processing these HSRP packets and it's telling you, okay, they're coming in here, here's the virtual IP that they're sharing, here's their authentication string, right? And if we go over to CDP, it's seeing broadcast from these two devices. And the CDP gives you all this information. There's our 2621, the fact that it's talking on F0/0. So, pretty easy to use. I mean, you can get all of this stuff with a sniffer. It's not like you need Yersinia for this, but it makes things a little easier. And you know, it also has a number of attacks that you can execute, which it does kind of well. Some things is better than others. Flooding the CDP table works like a champ. Take a network down with that thing, no problem. But we'll just use it kind of as a way to watch what's going on as we execute the attacks here. Now we're launching ScapeE. Okay, so there's a few things. ScapeE has support for HSRP out of the box. So there's a few things you have to give ScapeE in order for it to do its trick. The first thing is the source IP, which is the source IP of the Pineapple here, and the destination. This 224.0.0.2, that's the multicast address used by HSRP. So then we'll tell ScapeE, this is a UDP packet. We want you to send a UDP packet. We want you to send an HSRP packet that matches all of the characteristics of the packets that we've seen already. So this is the virtual IP. You can't really see it here, unfortunately. But we're giving it the virtual IP, the 190 IP address of that we see already is being used. We're choosing the group number, we're choosing the authentication string, and we're also setting the priority. So on HSRP, you can have a priority of 1 to 255, 255 being the highest. Out of the box, I think it's set to 100, and in this particular case, we have, I believe, HERP is at 110, and DERP is at 100. Should be able to see this here. Yeah, there it is, priority. It's in hex, but I think it's 100 and 110 and 100 is what we have right now. So let's go back. What'd I do? Okay, now we're going to actually launch the attack. And this command here just pretty much says, start sending these packets and just loop it all day. Just keep doing it all day. Oh, Yersinia sees the traffic. Interesting. So so we're definitely sending it. So if we come back over here and take a look at these guys. Oh, wait a minute. I just had a state change. So this is our backup router saying, I was standby, but now I'm going into listen mode because somebody else is standby. He's jumping out. Where'd my other console go? Thanks. And this guy is now standby. So we are the active router now. So we are taking all that traffic. It's all coming to us. That's how easy it is to become man in the middle for an entire VLAN. And you know, depending on what that VLAN is, that could be a really bad thing. If I'm a workstation, sure, that's bad. If I'm doing this on a server VLAN, that's probably a bigger deal. And then the other one we'll show is voidpopper, just for fun and games. We'll kill this off and let things get back to normal. Okay, so now we're pretending to be a phone with voidpopper. And if we come back to Yersinia and take a look what's going on. Oh, what's this? This is a new device, looks like a phone. It's running a software version of Ghost Dealers, that's weird. The platform is a Frisco Herp phone, 12. What? But it doesn't matter because all the switch is going to do is say, okay, you're a phone, I'll put you on the voice VLAN. And now you can go to town and do anything that you want to go after the voice devices. So, that's that. So, some conclusions from this whole mess. Ancient protocols are ancient, but so are the fixes. So it's not like we can't do anything about this. The tools to attack keep improving, right? But the same goes for the defense. You just have to buy them and implement them. You want some cheap network gear? Great, go buy it. You're not going to be able to defend against any of this stuff. It pays to pay for the good stuff. You can get security features out of the good stuff. It's a hard sell. Yeah. Right, exactly. This costs $100. So you need something more than $100 to defend against it. And the attack platforms are outrageous. This is insane. But defense in depth always offers the most protection. That's it. Any questions? All right. Well, thanks, Cleveland, for having a couple of Pittsburgh guys in, and we really appreciate it.